Okay, and then there's another issue regarding the gradient descent. If you see that, doesn't matter is it a gradient descent or least square error, it's depend on cost function. And that cost function, originally what I have explained before, it's one of the cost function that we are using is called as a sum of square error, which is SSE. And that is actually we discuss more. Okay, when we discuss more about we will discuss more about the sum square SSE, which is sum square error. And I think starting at the beginning, we always set or we always define our cost function as our sum of square error, meaning you are square your error and then you total up. That is called as a sum of square error. Okay, but if you realize that, okay, there's a that things, okay, actually when if you go back to this discussion, you find out that you can see over here for every one cycle of looping, okay, let's say one cycle of looping, you can see that each cycles you will update your beta, and you will find out when you update your beta, you always use, one sample come in, you update, and then another samples come in, you update your beta. So means that let's say you have a 1000 sample, so you will keep updating for each and every sample, means that 1000 times you will keep repeating 1000 times, and each time you take one sample, you will update your beta. Okay, that is how the original gradient descent work. But of course, if let's say if you talk about, not just 1000, let's say 2000 or 5000 data, and you do something like that, you keep repeating, means that now the training process or the hyperparameter tuning operation will, consume a lot of computational time in order to do that. So that's why that is what we do before. Okay, the one that we keep updating based on one input come in and you update your beta. Actually, there's a name for it. That, okay, the name for that is what we call as a batch gradient descent, meaning that you are updating your beta for each time. Okay, sorry, there's some correction there. As you can see that, okay, based on this algorithm, you realize that in order for you to keep updating your beta, doesn't matter is it beta not or beta 1, you realize that you need to compute the whole data. Let's say your data is 1000, then you to measure, or you need to total up the whole errors. Okay, that is why you call it as a SSE, okay, sum of square error. When you are set your cost function as a sum of square error, then this one will become, you will update, in order for you to update your B node, beta node or beta 1, you need to compute, okay, you need to measure all the predicted Y from the data, and then you take the actual Y, then you find the errors and the total up together before you can update your beta node and beta 1. Okay, so this is what we call as batch gradient descent. Okay, the one that we learned before is not just called as a gradient descent only, it's called as a batch gradient descent, meaning that each step of gradient descent uses all the training sample, meaning that once you take the 1000 samples, because imagine that like the previous example, we have 1000 sample, we just take the whole training data and then you measure the total error. That total error will use to update your beta here. Okay, but there's another but that kind of thing, actually there's a disadvantage. Okay, as you can see in this text, it's more stable error gradient, hence more stable convergence, and but more computational effort to evaluate error gradient if n large, meaning that if the n is too big, then it's required more time. okay, because you need to measure all error first. Let's say 5,000 errors, okay, that represent 5,000 sample before you can update your beta. So that is also not good for the gradient descent algorithm. So that's why there's another two mechanism that they try to propose, which is number 2, is called a stochastic gradient descent. So what is meaning by stochastic gradient descent? Meaning that each time you take the first sample, and then you just measure the error of, not you don't measure the total error. So if you don't measure the total error, sum of square, meaning that is not known as a sum of square error anymore. Okay, you are not sum together, you are just take the single error. Okay, it's not a total error, you just take the E1. Okay, you remember we have a total error E1 plus E2 up until En. No, you just take the E1. Okay, then that is you will put it here, means that now if you talk about this one, it will become, the equations will become something like this: beta j minus alpha, and then you just take the E1 here, E1 minus your x, okay, your xij, and your xj only, it's not I. Okay, so meaning that this one is, the definition is your fx fx1, this one is g, it should be g1, g1, and then this one should be your y1. Okay, yep, something like this. So there's no summations there, there's no summation symbols. Okay, yep, there's no summation symbols there. So that's how they apply the equation. Okay, just before that, actually there's no 1 over n here. Okay, there's no 1 over n. Later I will discuss why. There's a certain books they are using 1 over n. Okay, but now let's focus on this one. So you can see that this is how they update the beta, meaning that the new beta to be updated, then all beta must minus alpha, but the error is not the total error. You take the E1 only, meaning that each sample you count the error, you multiply with alpha, multiply with the input x, and then you update your beta. Okay, doesn't matter is it beta naught or beta 1. Okay, it depend on this part. Okay, depend on this one. Okay, so again, if you talk about the Beige, the stochastic gradient descent, then you don't have this one. Then this one become, you just measure the x of your, the x of this one, and then the loops there. Yep, there's no this one, and then there's no I here anymore. Okay, but you can put this I. If you talk about the first sample, this will become x1 y1, and then this one, there's no this mechanism anymore. This one is x1 y1 x1. Okay, then the next iteration, you will take the second sample, this will become x2 y2 x2 y2 x2. Okay, so that is what we call as a stochastic gradient descent. One input, one updating process, one input, another input, updating process. But the previous one, when we have this summation, actually is called as Beige normal stochastic gradient descent. Beige gradient descent, where you need to wait until 1000 because you want to total up all the errors before you can update your beta. Okay, so that is what we have discussed before, but now just want to show to you with some alternative approach. That is why I introduced to you with what we call as a stochastic gradient descent, where it will take a single training sample to update your parameter beta. Okay, and then of course there's also disadvantage by using this approach. Okay, so that's why as you can see that you can read there. Okay, reach the minimum mass faster. Okay, why they reach the minimum mass faster? Because you take one sample, you update the beta. So which is the computational time there is very small as compared to waiting to 1000 to total up the error to update your B. So meaning that the movement of stepping process towards to get the minimum value is quite quick as compared to, to complete one step in batch gradient descent, then you need to total up the errors. So that is the what we have discussed here. So that's why there's another approach, what we call as the third one is a mini batch gradient descent. This is the one which is always used in deep learning later. Okay, this one is actually is a hybrid. Okay, it's a hybrid between the Beige gradient descent and stochastic gradient descent. Okay, in order for you to understand this one, let me just draw one picture which is show you how to imagine this process. Okay, let's say this is one represent the whole data set that you have. Okay, imagine this is a 1000 data set. Assume that this is the same data set. I just draw it in three form, so then I can show you how is batch look like, how is the stochastic look like, how is the mini batch gradient descent look like. So assume this is your data set, 1000 data set, means that you have 1000 going to that direction, 1000 data. Okay, this is your, of course this is your X. Okay, your X, and then the last column here is your Y. Same. Okay, this one, the same data set. I just replicate the pictures. If you talk about the batch gradient descent, one cycle, in other words, when I say one cycle is one complete iteration. Okay, one complete iteration. Okay, when I say one cycle is one complete iteration, once complete iteration before you repeat at the second time. Okay, that is one cycle. Okay, another name for this one is one epoch. Okay, that is also you need to familiar. Okay, one time execution, this one is called as one epoch or one cycle. I just can say a simple typical word is one cycle. Okay, so if you repeat for the second time, that is the second epoch. Okay, second epoch if you repeat the second time. So cycle, you can use cycle, but you still need to familiar with the word epoch. Okay, so in one epoch or one cycle, okay, if you talk about the batch gradient descent, you need to run the whole 1000 before you can update your beta. Okay, however, for this one, which is called as a stochastic gradient descent, just take one sample here, you update your beta, and then meaning that one epoch. Okay, sorry, one epoch is not one complete cycle. I forget to mention that. One epoch is that if you already complete the whole 1000 sample, if you already use the whole 1000 samples during your training, that is called as one epoch. Meaning that if you talk about the batch gradient descent, okay, just go back to this slide. I just go back to this slide. Okay, this one is wrong. Okay, this one is not one epoch. I just said as a one cycle of iteration. Okay, one cycle of iteration is a one complete cycles before you compute with the next cycle. Okay, make sure that you clear about that. Okay, then what is epoch? Epoch, if you talk about one epoch, is actually when your algorithm already complete the one cycle of training. Okay, one cycle of training or update. Okay, one cycle of updating process or in other words is a one cycle happened when you complete the whole data. or in other words, you can also say that one epoch is when you already proceed the training process using that 1000 data. If you complete from the first one until 1000, then that is one epoch. Okay, so it's a little bit different from the cycle of your iteration. Okay, the iteration is this is the one that you need. I hope that you don't confuse, okay, because I using the same word cycle. There's a two different thing. One is epoch, another one is one iteration. Okay, one iteration is the looping process of your algorithm. Okay, first iteration, second iteration, third iteration. But one epoch means that once you complete update your beta using that full number of samples. Let's say in this case is 1000. If you already process this 1000 sample to update your beta, then that is called one epoch. But that does not mean one epoch and one iteration is similar. For example, this one. Okay, if you talk about this one, which is called as again, this is batch gradient descent. Okay, batch gradient descent. If you want to update your B, okay, you need to use the whole data, in this case 1000 samples, to update your B. Meaning that in one iteration you are already compute the total error of this 1000. In this case, if you talk about batch gradient descent, one iteration is equal to one epoch. Okay, because in one iteration, one loop only, you can complete the whole 1000 data, because you are calculating the total error before you update your B. Okay, now that is clear. I hope you clear about the batch gradient descent. However, for stochastic gradient descent, you just take one sample over here, you update your B, and then you take another sample, which is sample number 2, then you update again your B. So at the end, when you finish 1000 times, then you already complete 1000 times update your B. In other words, this one iteration is not equal to one epoch. Okay, it's more to 1000 iteration is equal to one epoch. Okay, so I hope you clear about that definition. Okay, but of course, this is just discussing about the difference between iteration and epoch. Okay, the word epoch and iteration. But I hope you also don't forget the concept over here. Why we have this kind of concept? Number one is what we call as a batch gradient descent. We just update the beta after we calculate the total error. That is what we have learned so far. We start with this mechanism, but of course this kind of thing have a disadvantage when your data is too big, because you need to wait until you complete one epoch to update your B, update your beta. So that's why they introduced with the stochastic gradient descent, where instead of waiting for total up the errors, you just use the error that happened at that samples E1, and then you update your B. So meaning that at the end, once you arrive at the one epoch, you already update your beta 1000 times, meaning the step is already 1000 towards to the optimum value. While this one, okay, after 1000 you only have one step only. So that's why if you can see the discussion over here, this one is a little bit slower, and this one is a little bit quick to arrive at the minimum value. Okay, but of course, there's also disadvantage of this one is reach the minimum faster than a gradient descent. But a frequent update may result the noisy gradient error, meaning that by having the small value. Okay, just take one sample, might it's not it will affected with some noise that might also make the one that you need to avoid. So that's why there's some people introduced with the third method, which is called mini batch gradient descent, where in mini batch gradient descent, what they do, they are separating the data into several batch. Okay, for example, I have 1000 again, I separate into 4 partition or 4 batch, means that each batch here consists of 250 samples. So what we do here, actually after 250 sample, we update our beta. Okay, meaning this is the first update, and then this is second update. Okay, update our beta, third update, and this one is the fourth update. So at the end, this one seem to be a combination between your batch gradient descent and stochastic gradient descent. Okay, just you update your it seems to be like you are updating your beta a little bit earlier than batch, but a little bit late from the stochastic gradient descent, because you already have a small batch here. This is what we call as a mini batch. Okay, but here if you discuss about the definition between the epoch and iteration, again this one should be to get one epoch, you need to proceed how many iteration? It should be 4 iteration. Okay, 4 iteration. Okay, so because you have a 4 partition here, this is one loop, second loop, third loop, fourth loop. This one is one loop only. This one is first loop, second loop until 1000 loop. So that's why 1000 iteration, one epoch. This one epoch equal to 1 iteration. This one is 1 epoch equal to 4 iteration. So this is the last one is the one of the is the common one that have been used in deep learning. Okay, they always use the mini batch gradient descent approach. Okay.